So the one problem with just using a point estimate, as we did in the previous example, just looking at the sample value itself, is it doesn't tell you how good that sample value is, right? If I say p hat is equal to 0.19 versus our p hat, our estimate, is equal to 0.165, you have no way of knowing which of these two estimates is more accurate, right? You might sit there and say, well, the second one has additional decimals, but that doesn't actually tell us how much information went into it. And that's why we need a confidence interval or a margin of error. And you see this all the time reported out in the news, right? This is the particular value plus or minus with a margin of error of this particular amount. So that's exactly how we create our confidence intervals. They are a symmetric interval about that point estimate where we add or subtract a margin of error. So you'll see me draw this picture again, but we're going to start with our estimate, which in this case is a p hat, a sample proportion, because we're estimating the true proportion. Again, this might be different in a different situation. And as a note, not all confidence intervals are symmetric. All the ones we learn about in this class are, because they're all got this underlying normality sort of going on. But if you were to make a confidence interval for, say, the population variance or standard deviation, that actually ends up being right skewed, and it has a slightly not symmetric, right skewed confidence interval as a result. So anyways, we're going to add a margin of error, we're going to subtract a margin of error, so all the ones we learn about, we're going to see this beautiful, symmetric confidence interval. And so we're going to look at the example we had at the beginning of the semester. That CNN poll of registered voters in California on whether they were going to vote for or against Prop 19. So as a reminder, when we saw this question before, feel free to take a moment, pause, and try out the parameter and statistic on your own. But we saw that CNN had surveyed 888 voters. As soon as you have that, I like to start just highlighting that entire sentence. This is going to be very useful as we move through. That entire sentence, anything given in the sentence with my sample size is going to be a sample value. So as we keep moving on, this 53%, that proportion or percentage here, is going to be a p hat because it's in the same sentence as my survey and my survey size. So that's my statistic. This is my p hat. We went out and took a sample, and 53% of them were opposed to Prop 19. Now, the parameter typically is not something we know. Typically, we will not know what our parameter is. That's where we're moving in this class. That's the idea. In fact, if we go back to the last example of 6.1, it said, suppose this value is true. We needed that a lot in 6.1 because there was always this underlying like, well, if the real P is, and now we're saying we don't know real P, let's try to figure it out. Political polling is one time that we actually do get real P at the end once the election is over. So in this case, we can see there's another percent running around, this 54%, and that was the actual percent of people who voted against Prop 19. So in this case, we actually have our P and it's 0.54. Typically, this will be an unknown value, and we would just leave this as P. And now it says, well, let's create a confidence interval based on the CNN survey. So this last piece, this margin of error, we're going to put that together along with this idea of how we create a confidence interval. So our 0.53, our estimate of 53%, we're going to add or subtract that margin of error to it. I like how I put everything in proportional, and it's just how I tend to do things. If we subtract, we always do the subtract first in our interval. And then we add, we're going to get this interval of possible values. So I think this is a good spot to sort of think about what you think this interval is telling us. What did CNN do with this particular survey? And so hopefully you're sitting there going, well, based on CNN's survey, we believe the real proportion of voters opposed, sorry, my handwriting is terrible because I'm trying to write fast, opposed to Prop 19 is between this 0.495 and 0.565. right? That's sort of the takeaway here. Based on the CNN survey, here's what CNN says. They're saying, I think it's going to be 53% plus or minus 3.5%, which means here. So there are two questions we could then ask ourselves, right? This actually has a lot of meat on it, which is why I chose this particular problem. One is, did CNN do a good job? And in some ways they did. We can see the real value is 54, which is within this range of values they thought it would be. So they did good. They caught the real P. That's the whole point of a confidence interval. It's sort of this attempt to catch this real value. If you watch that video from Mr. Nystrom, right? It's this P catcher. So we've caught the real P. CNN did a great job in that regard. But what CNN didn't do a good job at is predicting what was actually going to happen. Because if you look at these values, right, based on their survey, they believe the real proportion of people opposed to Prop 19 was between 0.49 and 0.56. At 0.49, this means less than half of people are opposed. This means that we're going to approve Prop 19, right? This means that marijuana would have been legal back in 2010 instead of whenever it became legal. So that would be the outcome there. Whereas if this is the truth, then of course what actually happened, and Prop 19 fails. We wait a couple more years before marijuana becomes legal. So we have these two different things. So in that regard, CNN did a really crappy job because we don't really know what the outcome is going to be. We can't make a prediction in terms of the outcome. Just because the majority of our interval is over in the more opposed range doesn't tell us anything, because all we're saying is I think the real value is somewhere in here, and if it's on this side, it's going to pass, and if it's on the other side, it's going to fail. So we're going to learn how CNN could have made this interval a little bit narrower so that they could have made an actual decision as we move forward in part 6.